Hi, this is Santosh and this is going to be my first video tutorial on VLSI testing. In that, I'll be going to discuss about D algorithm. Before going to discuss about D algorithm, we need to have a clear idea about stuck at faults, that is stuck at 0 and stuck at 1. I'll be going to discuss how to determine these stuck at 0 and stuck at 1 faults. Let us suppose we have a gate which is AND gate whose inputs are like 1 and 1 and whose output needs to be 1 as per our basic truth table, right? But if it is a stuck at 0 fault, even if they give 1 and 1 as the inputs, we'll get a 0 output. That implies this connection will be connected to the ground if it is stuck at 0 fault, and it will be connected to the VCC, like a power supply, when it is stuck at 1 fault. While manufacturing the chip, it will be connected to the VCC or ground with some basic defect. So even if we give the input, irrespective of inputs, like it is 1 1 0 1 1 0 0 0, whatever you may give the inputs, you will get the same output as it is connected to stuck at 0 or stuck at 1. This is stuck at fault basic. I hope you can understand. And now I'll be going to explain a simple D algorithm example showing how we need to determine the stuck at 0 or stuck at 1s and the basic test patterns. Like, see, here is an example for us. Here's a basic circuit with line 1 stuck at 0. So here it is stuck at 0. So we need to determine the test pattern, like what are the A, B and C inputs when the line 1 is stuck at 0. So in D algorithm, like in combinational circuits, we have 5 variables, that is 0, 1, 1 by 0, 0 by 1 and X. So you know that 0 and 1 and X is don't care. 1 by 0 implies D and 0 by 1 implies D bar. So in this D algorithm process, you should see that you will get the output even a D or D naught, not 0 and 1 or don't care every time. So I have line 1 stuck at 0. So line 1 stuck at 0 implies D. So if I have D over here, I need to get an output of D or D bar, depends on another input. So I will see that I'll get an output of D bar over here if it is 1. So I get a D bar, and you should always maintain that this D bar should be propagated till the output. So I have a D bar over here, and to get an output of D or D bar, you need to check the other other input. So if it is 0, D bar plus 0, that is D bar, and if it is 1, D bar plus 1, that is 1. So you should always take 0 over here. So you are done with the first path, like the path you have selected is 1 4 8 level. But in this process, you also need to check for the line justification. Line justification implies, so you have 0 over here. That means in OR gate, to get 0 over here, you should have 0 over here and 0 over here. So like you will have C0, and to get 0 in NAND gates, you should have both inputs 1 and 1. So here 1, here 1. So here it got stuck at 0 fault. So you should have 1 in this circuit, but it got stuck at 0. So you will have a 1 over here. So the B is 1, and the last test pattern that you will get is 1 1 0. I hope you can understand this very well. And I have a very big circuit which gives you a clear analysis of exactly what's happening. So for this circuit I'll be doing line 1, like line L stuck at 0. So this line stuck at 0. So you already know that line 1 stuck at 0 implies D. So you'll have a D over here. So the 3 steps that you should need to follow is fault activation, fault propagation, line justification. I have not explained these terms in the before circuit because I don't want to confuse you people with all these things without knowing the basic operation of the D algorithm. So fault activation is nothing but, so you have line L stuck at 0. That means you should have a 1 over here. It got stuck at 0. That implies you will have a 1 over here, like okay. So that implies, so you need to give that in the step of fault activation. You will have a k equal to 1 implies c equal to 1, and the fault propagation is nothing but the path which you are choosing to propagate your output till the end. So coming to fault propagation, I'll be taking this path 1 L sorry K L U T Z. So I'll be taking this path. So first we will check what exactly happens in the fault propagation. So I have D over here. So I need to get an output in D or D bar for the circuit to be testable. So to get D, if you take 0 over here, then you will get output of 1 over here. So to get D bar over here, you need to have both 1s. So A and B should be 1. So A is 1, B is 1, so and C, like as the line L got stuck at 0, you will get an output of D bar over here. So D bar comes here. Then for this gate to propagate the output in D or D bar, you need to have a 1 over here, right? So D bar into 1 is D bar, and as it is NAND gate, it will be propagated as D. So you got a D over here, and for this you already know that A equal to 1 implies this line is 1, so the output should be D. So we are done with the fault propagation now, and we are checking for the line justification. So you came through this way and you did your objective of getting D or D bar at the output for the circuit to be testable. Next, the line justification. So you have 1 over here. To get 1 over here, you need to have the inputs 1 and 1 over here. So to get 1 over here in the OR gate, you need to have so first we will check for this path. So this is AND gate. Again you need to have 1 and 1 over here. So it is 1 implies N should be 1. So N should be 1 imply, so M should be 1 here. So M should be 1 implies so this here at this step, to get 1 over here you need to have both 1s. By this D will be 1, so it should be 1 over here. So whatever may be the E, if it is 0 you will get a 1 over here and you will get 1. If it is 1 you will get 0 over here and it will be 1. So it is don't care, you need not bother about it even if it is 0 or 1. So in this case you got C as 1 and over here, so you need to have output of 1 and we have 1 input 1, so even if it is 0 or 1 your output should be 1, so it should be X. So our test pattern over here will be 1 1 1 1, don't care, don't care. That means you will have these many combinations: 1 1 1 0 0, 1 1 1 1 0 1, 1 1 1 1 1 0, 1 1 1 1 1 1. So I'm done. Thank you.